Problem number 1 states, a small child sits on the end of a diving board that is moving up and down with a period of 1.5 seconds. The amplitude of the child's motion on the end of the diving board is 0.6 meters, and they want us to find the child's maximum speed and maximum acceleration. And they also want us to determine if the child has to hold on to stay on the diving board. So, just started out by listing the variables given to us. We have our period of 1.5 seconds and our amplitude of 0.60 meters, and they want us to find the max speed and the max acceleration. So we can draw this this diving board oscillating on a circle. So circle represents one period, and we can set the starting position over here at A if we line this up on a position versus time graph. And I also noted that I started the angle of the position at 0. So for this particular question, that's not really going to matter because we're just looking for the max acceleration and velocity. But if we were looking for the velocity or acceleration at a specific position, we would need to know this angle here. So you can calculate that using A times cosine, cosine of A. But anyways, so we can take that and we can draw it out on a position versus time graph. So we have our amplitude here of 0.6 meters from 0, from equilibrium, and our period of 1.5 seconds. So this represents one period and two periods. And we can then take that and graph it on an acceleration versus time graph. So for the maximum velocity, we know that that's going to be its maximum when when x is equal to 0. So the speed is the fastest when x is equal to 0, and then when x is equal to negative a, that is when acceleration is going to be the maximum. So just to visualize here, we have our oscillation of the diving boards on a position versus time as well as an acceleration versus time graph. And now we can do our calculations. We know frequency is equal to 1 over period, so inverse of the period, which is equal to 0.67 hertz. We can calculate we want to calculate the angular frequency for our equations, so we can do that by just multiplying the frequency by 2 pi, and for that we get the angular frequency of 4.19 radians per second. And now we can calculate our max velocity just using that angular frequency times the amplitude. So we have both those numbers, plug those in, and we get our max velocity at 2.5 meters per second. And we can find our max acceleration by deriving that velocity, and that's just going to be equal to w squared times a, the angular frequency squared, which we can plug in those same numbers, and the maximum acceleration is going to be equal to 10.5 meters per second squared. And as far as if a child needs to hold on to the diving board, if he's or she is accelerating at a rate of 10.5 meters per second every second up until a speed of 2.5 meters per second, or about 5 miles per hour, I'd say, yeah, child probably has to hold on to not fall off. And this all ties into what we're learning in chapter 15 regarding oscillations and the dynamics of simple harmonic motion.